The last example in this section ties together all of the concepts that we've been discussing in this section and ties it together by asking two questions, even though it looks like it's only asking us one. So what it's asking us here is to find all the asymptotes of this function. But when it says find all the asymptotes, what we really want to make sure we look for is the existence of any horizontal asymptotes and the existence of any vertical asymptotes. So we have to check for both. I typically start off with horizontal asymptotes just because those problems are generally a little bit easier to solve. So to find any horizontal asymptotes, we'll look at the end behavior of this function. So we'll take the limit as x goes to infinity, and in this case we again only need to consider the leading term, so x squared over x squared, which is just the limit as x goes to infinity of 1. The limit of any constant is 1. And similarly, we could work out that the limit as x goes to negative infinity of 1 would also be 1. So in this case, we have a horizontal asymptote at y equals 1. So we found a horizontal asymptote. Now we want to check for any vertical asymptotes. So we want to go back to our original function and again look for any values of x that make our denominator equal to 0. So when is our function undefined? When is x squared minus 4 equal to 0? So x squared minus 4 can be factored as x minus 2 times x plus 2, which would mean we need to consider x equals 2 and x equals negative 2. So we'll start off by taking the limit as x approaches 2 of our function x squared minus 9 over x squared minus 4. We can go ahead and factor the numerator, or I'm sorry, factor the denominator. Factor both, actually. So we could rewrite this as x minus 3 times x plus 3 all over x minus 2 times x plus 2. So in this case, nothing cancels out. There's nothing that we can reduce here, so direct substitution still won't evaluate this limit. So instead, what we'll need to consider are both the right and left-hand limits. So we'll start by considering x approaching 2 from the right-hand side of x squared minus 9 over x minus 2 times x plus 2. So again, I'm going to be specific. The way I do this is to not write an equal sign. I'm saying that this is just approaching 2 squared minus 9 over 2 minus 2, which is going to be 0, but a 0 that's very close to 0 from the right-hand side, from the positive side, times 2 plus 2, or 4. So this is going to be equal to negative 5 over 4 times, again, that number that's very, very close to 0, but positive. So this 0 close to positive dividing by smaller and smaller and smaller values makes this head to infinity. And since we have that negative symbol in the numerator, this is headed to negative infinity. And actually, that's enough right there. We don't need to consider the left-hand limit. As soon as either the right-hand limit or the left-hand limit is headed to infinity, we know that we have headed to infinity or negative infinity. We know that we have a vertical asymptote at x equals 2. Now, we don't know the behavior of the function as we approach 2 from the left-hand side, but in this case, all the question is asking for are those asymptotes. So that's far enough to work that problem. But we still need to consider then the limit as x approaches negative 2 of x squared minus 9 over x minus 2 times x plus 2. So similarly here, nothing's going to cancel out, nothing's going to simplify. So here, we would consider, again, breaking this up into both the left and right-hand limits. So we would consider the limit as x approaches negative 2 from the right-hand side of x squared minus 9 over x minus 2 times x plus 2, which again isn't equal to but is approaching 4 minus 9 over, if we plug in negative 2, we get negative 2 minus 2 is going to be negative 4 times negative 2 plus 2 is going to be 0. But since we're adding something coming from the right of negative 2, so we're adding negative 1.99, negative 1.99999, we're approaching 0, but from the right-hand side. So this is going to be equal to negative 5 over negative 4 times 0 from the right-hand side. So because of the 0 in the denominator, that's positive, we're headed off to positive infinity. We have a negative over a negative, so those are going to cancel each other out. So becomes positive, and this is headed to positive infinity. So our limit is positive infinity. Again, once one of those one-sided limits equals infinity or negative infinity, then we know we have a vertical asymptote at x equals negative 2.